Okay, guys. Section 7.6, Systems of Linear Inequalities. This apology goes out to Jack. Jack, I'm sorry I didn't get this up earlier, but you know, I'm doing what I can, right? All right. Um, Guys, to solve a system of linear inequalities, the solution is just the area where the shadings of each inequality overlap. So what that means is, and I'm going to use this system here to the left. Oh, why is it doing that? Don't know. Don't know. Don't care. Moving this. There we go. Now, this is the system that we're going to be working with. All right, and I'm going to graph that thing. So I'm going to do the best I can to sort of graph it right here. The first one says x is greater than -2. So I'm going to go back here to -2, and I'll let this be my red graph. All right, and since x is greater than -2, this is a dotted line. And that means I'm going to shade to this side. Now you may be saying, hey Mr. C, why aren't you shading the whole thing? Right? Well, all I really want to shade is just the overlapping area. And that little bit of shading helps me remember which side I'm shading on. Okay? Now, the next one, it says y is less than or equal to 2. Alright, so I'm going to go up 2. Right? And a y is always a horizontal line. Alright, and it does say equal to, so this is a solid line. And it says that y is less than that, so I'm going to shade below. But the only part that I really need to I don't want to shade over here, because that's not a part of the solution. So I'm just shading in that little area, just to remind me where the shading is. So right now, and I'll erase this in a second, but right now, this quadrant where the blue is, right, this area right here solves both of those inequalities. But we're not done yet. All right, so let me get rid of that. Okay, now the last thing, and I'll put this one in blue, is this line, and it has a y-intercept of -1. So I'm going to go down 1 here, and I'll put a dot there. And the slope says go up 3, 1, 2, 3, and then over 1. All right, so there's another dot. Now, I'm sorry guys, it shouldn't say equal to. I want it to say that y is greater than or equal to. I should have made that an inequality. I didn't mean to make it a... There we go. That just looks bad. Let's see if I can figure this out. All right, how about greater than or equal to? Okay, that's better. All right, so here's my line. It says it's equal to, so I want this thing to be solid. Okay, like that. Now, since it says y is greater than, I'm going to shade on this side. Okay. Now you can see that the common area, the overlapping area, is this triangle. It's inside this triangle here, right? That's the area that all three of these lines have in common. And what that means is that if I choose any point out of that shaded area, it solves all three of these inequalities. So I'm going to take this point right here. You can see that point right there has its coordinates are x is -1 and y is 0, right? And it's in the shaded area. So if I plug it in to the first one, I plug in the x and I get -1 is greater than -2, and that's true. -1 is greater than -2. If I plug it into the green equation and I choose the y, that's going to say 0 is less than or equal to 2, and that's true, right? Because the 0 came from here, and I put it in right there. Okay. Now, if I plug it into the blue equation, I'm going to get the y is 0, and it's greater than or equal to 3 over 2 times the x, which is -1, minus 1. And I'll extend the page just a little bit to do the work here. 0 is greater than or equal to -3 over 2 minus 1, which is the same as 2 over 2. So 0 is greater than or equal to -5 over 2, and that's true. Okay, so you can see that that point that came from the shaded area, if I plug it into any one of those inequalities, it gives me a true statement. All right? Okay, guys, good job. That's what we're going to be doing today, and I'll see you at the first example.